positive charge, I've got 2 protons, so I have +2. I have, for negative charge, I have 2 electrons, so I have -2. So net charge is 0. It's a neutral substance. Everybody with me on that? We're going to do 1 or 2 more of those, just to be sure. Everybody okay? Don't be shy. The process is the same. And if you don't know, there's probably 3 or 4 others that don't know and they're too shy. Yes, sir?
I'm still kind of confused with the electrons.
Okay. If neutral, protons will equal, your number of protons will equal your number of electrons because each proton is +1. And if it's neutral, and we know it's neutral because no charge is showing.
Oh,
How would you know if it is?
Okay? If it's not neutral, there'll be a charge up there. Be a charge up there. That will be given. These, by the way, a preview of coming events. These are called ions. Ions are charged particles. That is a neutral atom. This is an ion of fluorine, or called fluoride. This is an ion of sodium, so it's sodium ion, not just plain sodium. So the charges show there. Okay, now, let's come over here and let's try another one. Let's say I have phosphorus. Find phosphorus up there. Right here. Okay, shout out. What's its atomic number? 15. What is its atomic mass to the nearest whole number? 31. Nearest whole number. Okay, you get that info off the periodic table. Okay, now let's fire down through here. Okay, on number of protons, how many? Anybody? 15. Okay, higher level math. How many neutrons do I have? 16. Good. See, these do not have to be the same at all. You just subtract whatever it falls out to be. Then, number of electrons, 15. 15. Because it's going to be the same as this as long as it is neutral. Okay, now, shout out. How much positive charge? Plus 15. How much negative charge? Minus 15. Net charge? 0. Excellent. Everybody okay? Give me a polite little hand gesture if you're not okay, and I'll do another. Yes? Okay. Each proton, from that previous table I had up there, each proton is +1 on that relative scale. So whatever this is equal to that, and put a positive sign. Each of these is -1. Now I know that's getting really messed up, but these two are going to be equal as long as you have a neutral compound. Okay, are we all right on that? Okay, and just another preview of coming attractions. And this, we'll have a lot more about this in chapter 4. But the very center, and this is a stylized drawing here, the very center of the atom is called the nucleus. Alright? And all of your protons and all of your neutrons are found in the nucleus. Out here, on energy levels, also called energy shells. Those words are used interchangeably. It depends who you're talking to, which they use. That's where you find the electrons. Now, atoms, of course, are three-dimensional. So this is a simplistic picture, but you could visualize. Of course, atoms are spherical. You've got the very center of it is the nucleus, where you find the protons and the neutrons. Then, for the time being, you can think of concentric shells, spheres, around that nucleus, and that's where you find the electrons. Here's a very important idea in chemistry. We, as ordinary chemists, just play with electrons. We never touch that nucleus. And so, when a chemical reaction takes place, we're giving away electrons, or we're stealing electrons, or we're sharing electrons. The action is with the electrons. Now, a nuclear chemist, a nuclear physicist, or at a nuclear reactor site, a nuclear bomb, you're talking about messing with the nucleus. And there you're talking about a tremendous amount of energy. But in ordinary chemical reactions, like what's happening up on 225 at those petrochemical plants, they're playing with electrons. And that's what we play with here. So, if something takes on a negative charge, it's stolen one electron if it's -1. Okay, if it takes on a positive charge, it lost an electron. It didn't mess with the protons, because if it gained a proton, something positive, it would not be sodium anymore. It would be magnesium. Okay, so, point is, we don't mess with the nucleus. Okay, we play with the electrons. So just for grins, let's do this. Okay, fluoride iron, negative charge. And I provide the charge for the time being. And its atomic number is still 9. And what would its atomic mass be to the nearest whole number? 19. Let's see if we can cope with this. Okay? First one out here. How many protons do I have? Tell me. 9. Okay? How many neutrons? Just anybody till I learn names here. We have 10. And again, see, those don't have to be the same. They're just whatever falls out when you subtract. Okay, careful. Here's what the difference is. If we become -1, we must have gained what? 1 electron. If you became -2, you would have gained 2 electrons. If you become -3, you must have gained 3 electrons. Okay, if you become +1, you must have lost 1 electron. If you become +2, you must have lost 2 electrons. And if you become +3, you must have lost 3 electrons. Okay, now, usually as high as you go is +3 and as low as you go is -3, just because it starts taking too much energy to steal more electrons or lose more electrons in that, so it's an energy game. So usually things just either become +1, +2, +3, -1, -2, -3. Okay, so for electrons, I'm going to hold my breath here. How many? 10. Excellent, excellent. Because if you were neutral, you would have 9. But we're not neutral. We're -1. So we must have stolen 1. So now we have 10.
If you were -2, you would just have a little 2.
I would have put -2 in that. Let's just see. It looked like that. Now, everything has a tendency to become a certain charge, and that's coming later in the semester. Like I know fluorine is going to become -1 if it becomes anything generally. Oxygen is going to become -2. Okay, so this is -1. Remember how we're too lazy to write the ones? Okay, so we've survived that much. Okay, what's your total positive charge? 9. +9. What's your total negative charge? -10. Net? -1. You see, this will be equal to the charge. Okay. Most people are nodding. Okay. Now, by popular demand, let's do it when it's -2. Okay, tell me the atomic number. Somebody shout it out. 8. What's the atomic mass to the nearest whole number? 16. Okay, let's hit it. How many? 8. How many? 8. How many? 10. Good. A little hesitation there, but it's 10. Because if it were neutral, it would be 8. But it's not neutral. It's -2. It must have ripped off 2 electrons from somebody else. So it's going to be 10. Okay, total positive charge. 8. Total negative charge. -10. Net. -2, fantastic. Good job, good job. Yeah,
The positive charge is equal to the burn-offs.
yes, yes. Okay, are we all right on these negatively charged ones?